Variables and tasks. So let's take a look. This is definitely one of the more advanced concepts, so get ready. A variable is a space in your robot's memory where data can be stored, including whole numbers, decimals, and words. Variable names follow the same rules as custom motor and sensor names. So you need to make sure it's capitalized the same way, spelled the same way, and that it's a word that you are allowed to use, that it is available. Variables can improve the readability and expandability of your programs, and I'll show you how. So you could call the word cleared a variable, and right now we have set it equal to the value 0. Then if we say that the encoder equals cleared, then the encoder has to equal 0. So these are different types of variables you can use. You are mostly going to focus on int right up here. That's pretty much all you're going to use unless you get super crazy advanced. Then you might start looking into creating a float variable or a boolean or a character or string, but for the most part we are just going to stick with int. So to create a variable, you must first give it a type, and int would be the type, and then a name. So we're going to call this variable the name rotations. You can call it whatever you want. You can call it pig pen, you can call it french fry, it doesn't matter what you call it, but you have to follow it by a semicolon. Variables are then set to different values throughout the program, and so the first thing you would want to do is give it an initial value, which is called initializing. So in this program we've first declared it up here, int rotations, and then set rotations equal to 4. So you can make a variable either local or global, and I'm going to give you examples of all of these here in just a second. A global variable can be read from any task in your code, and so it can be seen as read globally. A local variable belongs only to the task that you created, so it can only be read or changed from within that task. It can only be seen in that task, and it's generally the type of variable that you'll want to use as the local one. So here is an example. This is an example of creating a local variable, and I've called that the preferred method. You declare it within the curly braces of task main or of one of your tasks, and you're only allowed to change it within this task. So let's just ignore this stuff at the top. This is just setting up the sensors. You have task main, int rotations, and right now we have declared it and set it equal to a value all in the same line. That's just more efficient coding. So we've declared rotations and set it equal to 2, and then we've called that variable right here. We are saying start the motor at half speed until rotations, which is this number, and rotations is actually a number, which is 2. So it goes twice, reads the encoder, it rotates twice, and then it will stop the motor. Now we've changed the value of rotations to 4, and we run this program again backwards, but this time it goes 4 times. So that's one example of how you do local. Global variable, you declare the variable outside of the code. So in this one it says int rotations, it's outside of task main, and this actually should say task right here, task forward back. So if we want to call it, we would start task forward back, and then this again should say the word task. So if you're going to use a variable in more than one task, in task main and in task forward back, then we have to declare it outside of everything because we're using it here in task. Again, that's supposed to say task. Forward back, and then in task main. You can see rotations is used in both. So if that's the case, you'd want to declare it outside of everything. It's a global. If it's local, again, then you declare it, move backwards one here, you declare it inside task main. So I'm pretty sure you're going to have to reference this video again later when you start doing multiple tasks and variables, but here it is. So tasks are grouped together as several lines of code, and a task is usually referenced many times in task main or in another task. So if you need to do a chunk of code multiple times rather than actually typing that code out again and again and again and again, you can do it one time, make it a task, and then call that task just by saying call task or start task. So it's a really easy way to do repetitive code. So if you want to do a code where an LED is on if the bumper is pressed and off if it's released, then you would make a task header, you define the task, and then you call the task. So I'll give an example of all those. So here's a sample task LEDControl. We define the task or declare the task up here, task LEDControl, and then we have our regular thing we've always been using as task main, while forever, start this task, start LEDControl, which we don't know what that is yet, and run it until you hit the bump switch. So the task runs until you hit the bump switch, so that's kind of like the kill switch, and then immediately we'll stop all tasks, which also stops task main. So everything is done as soon as you hit that button. Well, LED control, this is where we define what LED control is. And here is LED control. It says if the sensor value bump switch is 1, if you push the bump switch in, turn LED on. It's green. Else, which means the bump switch is not pushed in, turn LED off. So the green LED is no longer on. So if you wanted to run this LED control in many different situations, then you might make this a task. Obviously, in this situation, it's probably not super necessary because you're only running it one time, but this is just kind of shows you how to set it up. So the first thing you have is a task declaration to declare that it exists. So this is what the task declaration looks like. Task LED control. The task declarations are between the # pragma, that's the setup of all of your motors and sensors, and task main. So that's where you would declare your tasks. I'll show you back here again. This is where you're declaring your tasks. It's between the stuff at the top and task main. You declare task LED control. We define it as writing what the whole code is. So task LED control, this is the definition, and then we put all our code inside that. So it looks similar to task main, but it's just task, whatever you call it. You call it anything you want. And then you put your code in there. And then to actually call it, the call has to be in task main, because task main is what the actual program is running. So we're going to do this as a forever loop, although that's really probably not necessary in this case. We could have just said start task until bump and then stop all tasks, because it doesn't actually loop back up, because stop all tasks also stops task main. Now there will be other cases where you do want it to loop back up, where a while loop would be helpful. So we've called this task start task LED control, and note the syntax, it's in parentheses followed by a semicolon. Then we have our until bump, you've done that many times, and then stop all tasks has an open and close parenthesis with a semicolon. So again, you probably need to reference this again. It's also in the assignment, so that might be able to help you out. And that is pretty much it. Once you get into the assignment, you're going to see more advanced versions of this that hopefully you'll be able to walk through and actually apply and use variables and tasks. Good luck.